Welcome to today's lesson on inequalities. We're going to look at linear inequalities, three-part inequalities, which are also called compound inequalities. We're going to look at some rational inequalities, i.e. inequalities with fractions, and some inequalities that involve absolute values. Some properties to remember when dealing with inequalities: that if we start off with a is less than b, then if we add some number c to both sides, whether that's a positive or negative number, doesn't matter, we still maintain the inequality that a is less than b. Or the new stuff, right? A plus c is less than b plus c. If we start with a less than b and we multiply both sides by c being positive, right? C being positive, then you can see we also maintain the direction of the inequality. However, if we multiply by a negative number, then all of a sudden the inequality changes directions. So that's the one thing to remember about inequalities, is when you multiply or divide by a negative number, the direction of the inequality changes. And that's what this is reminding us of, that it also works for division. Now, a linear equality in one variable just looks something like this. Don't worry about the specifics. Basically, it's just a bunch of x's and constants on both sides of an inequality sign, and we're just going to solve it like normal equalities. And that's the big thing to remember, is when we're dealing with inequalities, we use all the same tricks and techniques that we use to solve just regular equations. So it's not like we're learning anything new. Other than that whole division and multiplication by a negative, everything's the same. And we're going to try and avoid that situation anyway, so it's really going to be the same. Here's our first example. You can see that the way the book does it, they go for the shortest steps possible, right? They start with subtracting 5 from both sides, and then in order to solve for x, we've got to simplify our variable of interest, so we divide both sides by -3. And in a normal situation that'd be fine, but with an inequality we got to remember to flip the sign, right? Flip the direction of the sign, and we get x minus 4. I think it's safer, until you guys get really good at it, to just always avoid having negative x's, right, or negative variables. So first three steps all the same, right? You start with the equation, subtract 5 from both sides, get to -3x greater than -12, but instead of dividing both sides by -3, you recognize, you know what, I don't want a negative amount of x's, so I basically need to change sides, right? I need to move the -3 over there and the -12 over here. And what I'm really doing, in essence, is adding 3 to both sides, 3x to both sides, right? And so now I've got 12 is greater than 3x, and then, sorry. And so then the next thing I do is add 12 to both sides. And so then I end up getting 12 is greater than 3x, and then when I divide both sides by 3, I'm back to 4 is greater than x, which is the same thing as x is less than 4, right? 4 is greater than x is less than 4. It means the same thing, but we didn't have to worry about dividing by a negative. So my suggestion is keep x positive. Here are my basic simple set of 4 steps, 5 really, but the 5th step is just check, for solving any equality or inequality. You'll notice that I'm doing both of them at the same time, because it doesn't matter if it's an inequality or a straight equality equation, right? So the first step is to always get rid of all your fractions, decimals, and parentheses. These are the things that trip us up. These are the things that make us panic when we see them. So if we can get rid of them, we can now have a much simpler, easier something to deal with, right? Whether equation or inequation. The things in red are basically just what these steps entail. So in order to get rid of fractions, decimals, and parentheses, that normally means that you're multiplying through by a constant, or you're distributing through to get rid of parentheses. The next step is to combine like terms on both sides, which really just means you're going to add and subtract a bunch of things. The next step is to isolate your VOI, your variable of interest. And the reason why I call variable of interest is because as we get better, we're going to start dealing with equations with more than one variable. So for now, we're only going to have one variable, a bunch of x's, or maybe a bunch of a's, or a bunch of p's, or something, but only one variable. Later on, we're going to have 2 variables, and we're going to need to solve for one of them. So the only thing we have to realize is that when we're isolating a variable, we're just isolating the one we care about, our variable of interest. And we always want to keep it positive. So that means we're going to, move them all to one side or the other. It doesn't always have to go to the left. We can move everything over to the right side if that's what it takes to keep our variable positive. The next step is to simplify the VOI, which really just means divide both sides by whatever its coefficient is. And then the last step, the check step, is whatever answer you get, you should plug that back into the original equation, not any of the steps, right, but all the way back into the original one, and check your results and make sure that everything works out. So here's an example, a nice ugly looking thing. It's got fractions, it's got decimals, it's got parentheses, it's got two different variables. It's as bad as it's going to get. And you'll see that it really isn't that difficult at all. So step one, get rid of fractions and decimals. So I see right off the bat I have this fraction and I don't like it. It makes my head hurt. So in order to get rid of 1/2, can't I just multiply by 2? And I just have to multiply everything by 2. So I just get negative 6x minus 1 plus 4 times x minus 0.4, right, equals 10y plus 2 times x minus 2, right? All I did was multiply everything through by 2. Don't forget that when you have something like this, a product, when you multiply a product by 2, you don't multiply both pieces by 2, just one of them. So 2 times 2 is 4, and the other piece is just going along for the ride. Okay. Next, I want to get rid of parentheses or decimals, right? I can get rid of this decimal, but it's trapped inside a parentheses. So let's get rid of the parentheses first. And in order to get rid of the parentheses, all we have to do is distribute. So minus 6x minus 1 plus 4x, right? Minus, well, 4 times 0.4 is 1.6 equals 10y plus 2x minus 4. Okay, so now we're left with just this ugly decimal that we don't like. And to get rid of a decimal, all we have to do is multiply by tens and powers of tens, right? If there were 2 decimal places here, we'd have to multiply everything by 10 twice, or 100, right? If there were 3 decimals, 10 cubed, or 1,000. Since there's only 1 decimal, we can multiply by 10. Now I know a lot of you are saying, well, shouldn't I combine like terms first? If you want to, you can, but I like to stick to my steps in the order that they are. That way I don't have to really think a lot from question to question. It's always just the same steps. So multiply everything through by 10. Negative 60x minus 10 plus 40x minus 16 equals 100y plus 20x minus 40. See, now they're all whole numbers, easy to work with. Even though they're big numbers, they're not too difficult. We can deal with those just fine. Okay, so now the next step is combine like terms on both sides. So I've got some x's here and some x's there. So I put those together and I get negative 20x, right? And then I've got negative 10 and negative 16, so that's just negative 26 equals, well, that's my only y piece, right? So it's still just 100y. That's my only x piece, and that's my only constant. So nothing to combine on the right-hand side. Okay, so now we move on to the next step. Isolate our variable of interest. Now I didn't tell you what the variable of interest was here. It's going to be x, right? If you hadn't already guessed, we don't care about y. We're just going to treat it like a constant, a quote-unquote unknown. X is the thing that we're solving for. So we want to combine our x's, and then we want to put everything else on the other side of the equalities. But we want to keep x positive, right? So if I move this x on the right over to the left, I'm going to have negative x's. And it's going to be a lot better if I move the 20 over to that side. Now it doesn't really matter because we're dealing with equations right now, right? But what if this was an inequality, right? What if I turn these all into a greater than or equal to? Then it does matter. So let's add 20x to both sides and have negative 26 greater than or equal to 100y plus 40x, right? Because I added 20x here and I added 20x here, and then minus 40. So now I want to get these two pieces over to the other side, right? So I'm going to subtract 100y, and I'm going to add 40. So I'm going to add 40 to this side and subtract 100y. So I'm going to have minus 100y plus 40 minus 26 gives me a positive 14. So plus 14 greater than or equal to 40x. Right? Move the 100y and the 40 over. If you don't feel comfortable with that, move them one at a time. So that's isolating our variable. Next thing is simplify our variable, which means just divide by the 40, right? So divide this by 40, divide this by 40. And of course it'll reduce a little bit, right? They're all divisible by 2. So we can have, and I'm going to rewrite this as 7 minus 50y all over 20 is greater than or equal to x. And that's it. Now, of course, just to check it would be a nightmare because this is a big ugly thing to have to plug back into our x's. So I wouldn't probably waste the time doing it like this. But if we didn't have the y and we actually just had a number, it wouldn't be so bad. Okay, so those are the 5 simple steps, really 4 if you don't count check. We've seen this before, that we can list our answers 3 different ways: in set builder notation, interval notation, and with graphs. So nothing new there, nothing new here. They're just showing you all the different types of solutions you can get. Here's another example that the book set up. You can pause and look through the steps, right? You're subtracting 4 from both sides, you're combining like terms, you're adding 3x, so that you're basically in that step you're isolating your variable, right? And then combine like terms again, subtract 3, which is more isolating of your variable, combine like terms again, this is a continuation, divide by 5, and lo and behold, there is our solution. X is greater than or equal to negative 3/2, and so this is what it looks like over here on a number line, and this is how we would write it in interval notation. Another example involving the world of finance, revenue and cost. So we've got our revenue equation of 4x, our cost equation of 2x plus 1,000, where x is the number of units produced and sold. They want to know at what production level does R at least equal C. So that's a big fancy way of saying make sure that revenue is greater than or equal to cost, or i.e. 4x is greater than or equal to 2x plus 1,000. I would move the 2 over here and have 2x, right? I'm subtracting 2x from both sides, greater than or equal to 1,000, divide by 2. And it looks like we need to produce 500 units such that revenue at least breaks even or is greater than cost. And they get the exact same thing. Now, a 3-part, right, or a compound inequality. You can see where you've got x in the middle and then some numbers on each side, right? So x is simultaneously greater than something and less than something else. The rules still apply. You would still get rid of all fractions, get rid of all decimals, get rid of all parentheses, then combine like terms. Only now you're doing it for 3 pieces, right? So you combine like terms on the left, combine like terms in the middle, combine like terms on the right, you know, blah, 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 blah. So there's nothing to combine. So the next step is to isolate our variable, and we want to leave our variable in the middle. So we need to get rid of this 5. So we subtract 5 from all 3 pieces, right? So now we're here. Then we divide everything by 3. We're trying to simplify our variable, right, with that step. So we divide everything by 3, and there's our compound solution. And if x is in between those 2 numbers, then this is our solution written in interval notation. Here's another example that actually involves a fraction. So same thing, right? In order to solve it, first step, get rid of fractions. So I'm going to multiply everything through by 2. 2 times 0 is still 0. 10 minus x less than or equal to 6. Now we can breathe a sigh of relief. It seems a little easier. So get rid of this 10. Minus 10 less than negative x less than or equal to negative 4, right? We've got to subtract 10 from all three things. So I subtracted here, subtracted here, subtracted there. Now this is a bit of a pickle because we're stuck with negative x in the middle. And I know before I said it's nice to, we try to keep our x's positive, and we always do, but we can't do that with these compound inequalities. It's easiest to just leave the x in the middle. So we're now stuck with having to divide by negative 1 in order to just have x, right? So I'm going to divide by negative 1, and when I divide by negative 1, what happens to my signs? That's right, they flip. All right, divide by negative 1, divide by negative 1. And now I hate it written like this, so why don't we visualize having this on a, a see-through chalkboard that we can spin it around and just write it this way. Because it makes more sense. I mean, sure, it's true that 10 is bigger than something that's also bigger than 4, but it's just kind of nice to put it in the order of the number line, because now if we wanted to draw it on a number line, we would see that we would go from 4 up to 10, right? Square bracket, round bracket, everything in between. Or if we wanted to write it in interval notation, 4, 10 with a round bracket on that side. Okay, so just some vocabulary. When you hear people talking about strict inequalities, those are ones that are strictly less than or strictly greater than, and then the non-strict ones are the ones that are greater than or equal to or less than or equal to. And we saw some examples of those already. Example 5, right? We had a strict inequality, and example 4 was a non-strict. Solving a rational inequality is a little different. We want to rewrite the inequality if necessary so that we only have a 0 on one side of the inequality sign, and then the fractional stuff is on the other side. And then all we have to do is find the values that make the numerator and denominator of the rational expression equal to 0. So that entails having to factor out your rational expression if it isn't already factored, and then just set each of those factors equal to 0. So you're kind of like finding zeros again. Step 3 is you then plot those numbers on a number line and use some test values in each interval to see which ones, where it works, where it's less than 0, where it's greater than 0, and those types of things. So a caution we have to worry about with these things is a lot of students would look at this and their first instinct would be, oh, I got to get rid of fractions, right? So I'm going to multiply both sides by x plus 4. So I can get rid of this fraction. But what's the problem with that? Why can't we multiply both sides by x plus 4? And if you haven't read down here and cheated, hopefully you're thinking about, well, when I multiply both sides by a positive number, this stays where it is. But when I multiply by a negative number, it has to switch like that. And since x is a variable that can take on infinitely many possibilities, sometimes x plus 4 is positive, so it doesn't switch directions, and sometimes x plus 4 is negative. Think about if x was 0, you're fine. But what if x is negative 10? Now it's a negative number and you have to change directions. So that's why we can't do this, because we don't know what to do with the signs. Sometimes it stays, sometimes it flips. So instead, we have to do this. We have to subtract 1 from both sides and then have 0 set up on the other side of the inequality. And now we need one big fraction, right? Because we can't determine where this is equal to 0 on the left-hand side, because we've got, a polynomial basically. So in order to make it one big fraction, we have to do a common denominator. So we make negative 1, we turn it into just negative x plus 4 over x plus 4. Now we can combine everything. 5 minus x plus 4, right? Quantity. Remember, it's quantity. So it's always a good idea to use parentheses to remind yourself of that. So then the next step is to actually do the math, right? They kind of, they might lose you here if you don't pay attention to what's going on. You've got 5 minus x minus 4, 5 minus x minus 4 when you distribute. So this ends up being 1 minus x. And that's where they get 1 minus x over x plus 4 on this next slide. Now the idea is, When does the top equal 0? Well, that's just when x equals 1, right? And when is the bottom? Well, that's when x equals -4. So there's the two, you can think of it as the two zeros of that rational function. Then you come over to the number line and you graph those two zeros. And you go, okay, here's the 2 points where I have the two zeros I got before, -4 and 1. And all you do is pick a test point in each of these three intervals and put it back up into the original function and see if it's true or false, what's going on. So the idea is to always pick the easiest numbers possible. So in this interval, any whole number is going to do. So let's pick -5. So if we plug -5 into this function, we get 5 over -5 plus 4, which is 5 over -1, right? Which is -5. And is it true that -5 is greater than or equal to 1? And you go, nope, false. That interval doesn't work. So then pick a number in this interval. Well, any interval that contains 0, 0 is the best one to pick because that's the easiest, right? Because if you plug in 0, you just get 5 over 4. Easy peasy. Now, is that greater than or equal to 1? You go, well, yeah, 5/4 is bigger than 1, so this one's true. Yay, we found where it works. And then check the last one, right? So I'm going to pick just 2 because it's nice and easy. And so then I have 5 over 2 plus 4, which gives me 5/6. And you ask yourself, is that greater than or equal to 1? Right? And you go, no, 5/6 is less than 1, so this is false. Now, it's not always going to alternate like this, right? It does tend to do it a lot, but it doesn't always do that. You do have to choose every single interval. The last thing you also need to check are the actual points themselves, right? So when you plug in 1, you get 5 over 5, which is equal to 1, and that works. But when you plug in -4, you get 5 over 0, which doesn't exist. So that's an open dot, right? That one's no good. So this next page is what we just did, and it's showing the false, true, false. And so the last thing to do is to kind of put it all together, which is what they're talking about here. And we'll just do it on this slide so it's all in the same place. We figured out that it's true there, it's false everywhere else. So the answer is just going to be -4 to 1 with a square bracket, right? Because we figured out that 1 actually works, so we can have a square bracket, but -4 doesn't, so we have to have a round bracket there. And that's as simple as that. Here it's just reminding us to always check those endpoints, i.e. the actual zeros, right, to see if they work or not. Let's look at a couple more examples. Same thing here, right? They started with a number on the other side, so we've got to move it over. Then we came up with a common denominator, and then we're going to have to distribute. So we're going to be 2x minus 1 minus 15x, right? Minus 20. So there it is, minus 15x minus 20. Combine like terms, get it all down to there. The next thing you're going to want to do is try and factor it out, right? Simplify it if you can, but there's really nothing you can factor out of that other than maybe a -1. So they're bringing you back to the original equation here, which can get a little tricky. So let's just stay on this slide instead and say from here, figure out where does the top equal 0. So -13x minus 21 equals 0. -13x equals 21. X equals 21 over -13. That's an ugly number. -21/13. And then the bottom, right? 3x plus 4 equals 0. So 3x equals -4. X equals -4/3. Not much better. We would go to our number line and we would put these two on the number line. So we've got -21 over 13 and we have -4/3. We have to check each of these zones, right, with our original equation. So I'm going to pick something in the first zone. So negative 21/13 is a little bit bigger than negative 1, so I'm just going to go straight to negative 2. So I'm going to plug negative 2 in here, and I'm going to get negative 4 minus 1 over 3 times negative 2 is negative 6 plus 4. I have to ask myself if that's less than 5, right? So I've got negative 4 minus 1, so that's negative 5. And on the bottom, negative 6 plus 4, negative 2, the negatives cancel, and I get 5 halves. Is 5 halves less than 5? Well, yeah, 5 halves is 2.5. That's less, so this is a true. So that one works. Okay, let's pick in between these two. This is 1 1/3, and this is negative 21/13. That just sucks trying to find a number in between those two. So you're probably going to have to do a common denominator with your fractions and then find a number in between them. Let's skip it and try this one instead, the easier one. Obviously the best one to check here is 0, right? Plug in 0, we get negative 1 over 4. Is that less than 5? And yep, that one works as well. Now rather than spending a lot of time going over the middle one, let's check here and see what they're telling us. There's our 3 intervals. They chose those 3 points and found that the middle one didn't work. I'd suggest going and spending some time and double checking that, right? But then there's your solutions, right? We found the left-hand one worked, the right-hand one worked, but we didn't check to see whether these should be round or square, right? We know these have to be round because you can never have square brackets on infinity, but you always got to go back and check your endpoints. Well, because this was a strict inequality, you can't equal it, so you can never have square brackets on these. So you don't even have to worry about it. They're both going to be round, right? So they're both round. Just like they said, these are round. Okay, one more example of these. This one's a little bit easier because we don't have a number over here. We don't have to bring it over. So we're pretty much good to go as it is. All we have to do is set the top equal to 0, set the bottom equal to 0, and solve. So it's nice to leave it factored out because now we know our zeros are at 0, 4, 2, and negative 3. So here's our number line, right? 0, 2, 4, negative 3. So let's pick numbers in each spot. So I'm going to pick a negative 4. Plug negative 4 into this thing, and I get negative 4 times negative 4 minus 4, which is negative 8, all over negative 4 minus 2, so that's negative 6, times negative 4 plus 3 is negative 1. So I get 32 over 6. Right? Because that becomes positive, that becomes positive. That's a number that's, bigger than 5, so it's not less than 0. That's a false. Then I go to between negative 3 and 0, so let's just do negative 1. Negative 1 times negative 5 over negative 3 times, looks like 2, right? Negative 1 plus 3. So the top is going to be a positive 5. The bottom is going to be a negative 6. That's going to be a negative fraction, so it's less than 0. So true. Go over here, choose 1. Right? So then I get 1 times negative 3. 1 minus 4, right? Then 1 minus 2 is negative 1. And then 1 plus 3 is positive 4. So this is going to be negative 3 over negative 4, right? And that cancels and just gives me 3/4, which is not less than 0, right? That's a positive number, so that's false. In between 2 and 3, we're going to use, in between 2 and 4, we're going to use 3. So 3 times negative 1, that's a 1, right? 3 minus 4, over 3 minus 2, which is 1. 3 plus 3 is 6. That's negative 3 over 6. That's a negative number, so that's true. The last one to choose is bigger than 4. Let's pick a 5. So 5 times 1 over, what's that, 3 times 8. Those are all positive, so it's a positive number, so that's false. So here's our two winning spots. So our answer is from -3 to 0 and from 2 to 4, but we've got to check our endpoints, right? Because this is less than or equal to. So with -3, the bottom's bad, right? That's a bad number because then we get 0 on the bottom. With 0, we're fine, doesn't mess up the bottom. So 0 is good. 2 is no good, and 4 is good. So that means can't have 3, but we can have 0. Union, can't have 2, right? So there's my 2, but we can have 4. All right, the last style that we have to worry about is when we have absolute values. And these are a little odd, but they're not too bad. The first step is to basically just erase the absolute value symbols and just solve it as it sits. Then you go back and start all over again, rewrite it just the way it was, get rid of the absolute value symbols, but then change the direction of the inequality and multiply one side by -1. It's usually easier to multiply the thing that wasn't in the absolute value to begin with. And let's do an example, you see what I mean. Okay, so here's a simple example. Step 1 is to just consider it the same thing, right? But without the absolute value symbols, and solve normally. So we add 4 to both sides and we get x is less than 5. Simple, easy. The step 2 part is to do this, right? Change the direction of the signs and then multiply one side by -1. It's easiest to just do the right hand side instead of all this stuff. So we just set it greater than -1. And now we solve like normally. Add 4 to both sides. And there we go. X is less than 5 and x is greater than 3. So from 3 to 5, round brackets, right? Everything in between. Or if we wrote it as an interval, from 3 to 5, round brackets. Simple, simple, simple. That's all it means. Is you're basically solving two inequalities. One more, last final example. So again, drop the absolute values, solve like normally. So we add 3, then divide by 3, right? Okay, then the second step is less than or equal to -15. Again, add 3. So add 3 to this, you get -12. Divide by 3, -4. So now you have x is less than or equal to -4, but it's also greater than 6. So that's one of those two-piece ones, right? Where you've got -4, everything in that direction, and then 6, everything in that direction. So you have to write this as a union, -infinity to -4 square brackets, union square bracket 6 to infinity. Okay? It doesn't matter how complicated they get, the rules are still the same. You know, if we had absolute value of 2x plus 7 greater than, let's say, x minus 2, then we would have 2x plus 7 greater than x minus 2. We would solve that one. But then for the second case, we would have 2x plus 7 less than, and remember you have to multiply the whole thing by -1, so it becomes -x plus 2, or you might want to write it as 2 minus x, right? And that's it, right? You would solve each of those as a simple inequality, and then whatever your answers were, you would either combine them because they went inside towards each other, or you'd have the little union thingy because they went in both directions. And that's it, guys. That's everything we have to worry about for inequalities.